Okay, so we have talked about cross sections when you do your bread slice. So now we're going to talk about what happens. These are called solids of rotation. Okay, so here's a little quiz for you. It's not like the last quiz. I know. Okay, so we have this area here, right? This would be an area. Imagine this being a graph underneath a curve. If I were to rotate this 360 degrees around this line, what shape will I get?
It's a sphere.
It's a sphere. Yeah, it's not a circle. Hooligan. It's kind of falling apart, but right. I stole this from a party somewhere. It's not gonna go. There you go. Right? It's gonna be a sphere. We'll just ignore the fact that it doesn't go all the way around anymore. It's gonna be a sphere. Okay? That's a solid of rotation. A solid formed by rotating an area 360 degrees.
Okay. It's similar to how we solve those questions with the paper.
Yes, exactly. Okay, so here you have a boot. Boot. Lovely shape that it is. What will it make when I rotate it 360 degrees around?
Shape.
A circle boot.
It's a bell.
Bell.
Right? Yeah, very
That's
exciting.
a good one.
Yeah.
Jellyfish.
Oh, like a jellyfish, like the one in Finding Nemo.
Like
It
a
reminds me of the one in Finding Nemo. Okay. Ken, how about this one? I don't even know what you want to call this. I did steal this from somebody's open house because they were in calculus. And I was like, this reminds me of that. She's like, you can have it. That's
Wow.
a Coke bottle. Looks like a Coke bottle, right?
There's like a nose of a horse coming out or something.
Well, don't ignore it. I mean, just ignore that.
Oh, it's been.
Yeah. Okay.
Yeah, a bell again.
It's like a no. It's actually like a like a UFO,
No.
right? It's just like a flower, pretty much, right? It's like a UFO, but it's got a.
So was that for a fan at the open house?
They were just hanging.
That seems like a really weird shape to find the area of.
Well, I didn't say. So I want you to think about this. So if we were to, let me get my notes. This actually, Mason said that he's not looking forward to the shape changing. This actually is going to make your life easier. Yep. Okay, so let's say this is lesson 6. We're going to call it, it's 6-2 part 2. Because your book crams a whole lot into 6-2. So let's say we have this shape. And we want to talk about rotating it around the x-axis. Okay, so that little thing is just a reminder to me that I'm going around the x-axis. It's like an arrow that's saying go around the x-axis. So here's what I want you to think about. We make a slice. Don't worry about, we would have to find the intersection points and all that jazz, but I want to go with the foundations here. We make a slice and we pull it out. It's a rectangle, but we're rotating that slice 360 degrees. What shape does it make?
Cylinder.
It's a very skinny cylinder, right? So this is, I actually cut up one of these other things. Look, like here's your strip, right? Here's your strip. And so what it makes is a little cylinder. Okay, notice it doesn't have the UFO part on it. It's just a cylinder. So the beauty is that a cylinder always has the same formula, right? So it's going to be really easy. So what I tend to do on mine is I'll draw myself a picture of the cylinder, skinny little cylinder. Do it, don't do it, I don't care, but I would recommend doing it just because I know it's coming, okay, because there's a little bit more coming down the pike. The radius of this, we're going to call this F. What's the radius of it? F of X. So, and what's the height of it? Dx. Okay, so then what's the volume of one cylinder? Come on in, Brayden, and have a seat in the back. Oh, perfect. Thanks for the message. Goodbye, stats kids. Okay, what's the volume of one cylinder?
No. Pi r squared times height.
Pi r squared times the height. Cylinder, right? Pi r squared times the height. So pi times f of x squared times the height, which is dx. That's the volume of one cylinder, and then we would do the integral to get all of them. So the beauty of this is that it's always pi r squared, right? When you're talking about that rotated solid, it's pi r squared to make your life easy. Okay, and you're using your calculator to do this 9 times out of 10. So
That's a song. 9 times up.
good. Didn't know that.
G or an arrow?
This is an arrow because we're rotating it around the x-axis.
I just wondered if you were marking it.
Why do we always put the interval
Zero
there?
G.
We just leave as much outside as we can.
Constants outside.
Okay.
You can put it in if you want. I just like to put it up. So let's actually do that. So let's say we have the function f of x is equal to, let's go x cubed. So it's this function, it's first quadrant area, or first quadrant area between x cubed and x equals 2. Okay, so just like the rest of them, it's probably a good idea for you to draw a picture. And I have to give you more information. We're rotating this around the x-axis. Okay, rotating it around the x-axis. So, draw yourself a picture.
This only works for shapes that are like round from the top, or round from one to the side.
Or rotated solid.
X equals 2 is what I was in straight line.
That's why it's rotated. It's got to be rotated. This is called a solid of rotation. That's why.
Miss Doctor,
What?
X equals 2 is what I'm in straight lines, right?
Yep.
To the y axis.
First quadrant. Okay, so if we graph x cubed, oh no, we don't care about what happens down here, but it looks like this. Don't care, and then it's this. Okay, so it's this. What you hear the AP test or see the AP test say is that this is a region. They usually say that this is region R, right? So we'll call it R. And they'll say, find the volume of the solid generated by rotating R around the x-axis. Okay, that's how the wording would be. Doesn't really matter. It is. You're right. It doesn't really matter. Okay, you don't have to worry about what shape it is. That was just to get your brain thinking. So when you think about this, okay, when you think about this, there's your slice. We're rotating it around the x-axis. It will be a cylinder. Anytime you see that rotation, it's going to be a cylinder, based on a cylinder. Okay, so cylinder, dx is the height. What's the radius? X cubed. Yep.
So it goes to the origin.
Nope. So it's taking here and you're spinning it around 360 degrees. So I cannot draw this, but it would, three-dimensionally
It's like a top.
look like that.
Okay, so if it like ends up like it looks like it's going circular, if you would spin it around much times, then it's so.
If you see the word rotated around anything.
Okay.
Okay, so x cubed is the radius. Now, what's the volume of one of these?
It's going to be x3 squared.
X cubed squared
X
times dx times pi. Right, because
goes out front, though.
yeah, pi goes out front. Pi radius squared. So pi radius squared times height. There it is. We're integrating to get all of those little cylinders from where to where? 0 to 2. Now, pop that sucker in your calculator and you have the answer. Okay, just so that you know, I'm going to ask you to do one of these without your calculator today because that's the way we've been not doing things. Okay, go ahead and find the answer. Now, it is a nice idea to keep this exact and in terms of pi. So super easy, just don't put the pi in there. Do the integral of all of the stuff and then slap the pi on the end.
64.
Is it? It came out nice?
I did it without a calculator.
No.
18.285.
Okay, that sounds more right.
Well, isn't 2 cubed 8 and 8 squared 64?
It would be 6, x to the 6, but you would have to do the antiderivative.
Yeah, without adding the pi on the end, I got 57.446. So divided by pi.
Yeah, me too.
That, you mean that's with the pi?
That was with the pi.
Maybe with the pi, like multiplied by.
Yeah, so
But I like without, like, the pi.
18.286 pi. Honestly, your AP test would be most likely to give you that in terms of a fraction, 128 pi over 7. Okay, because this would be, oh, maybe not. 2 to the 7th is a little bit larger than they would probably ask you to do. But otherwise, it's 0.
Is the AP test time? It
Yes,
is, right? Okay.
it's okay. So you guys try. Let's go. Let's say f of x is equal to the square root of x minus 2. And I would like the first quadrant area. Second, I gotta graph it because I'm pretty sure I'm gonna screw it up. Square root of x minus 2. Yeah, I was gonna screw it. Okay, first quadrant area bounded by the graph and the line x equals 7, and I would like rotate it around the x-axis. Okay, I'd like you to do this without your calculator. Okay, this guy, his graph looks like this. I'll even tell you. Looks like this. This is 2. Okay, so first quadrant area right here, rotated around the x-axis. I was very nice to you here.
And this, for this, we can distribute it, right?
Simplify.
Yes.
Please simplify.
Okay.
That's why I gave you what I gave you.
And I'm gonna plug 7 in.
So when this. The only thing that I don't get with this graph. When the square and radius or cube you square it every time afterwards when it's in the integral.
Yes.
What I need to know is how the x before was x cubed because the graph was x
Because
cubed.
the graph was x cubed.
Okay, so it's gonna be square root of x minus 2
Square.
square.
So that's like,
Final answer is x equals, right? Or do we just?
no, just equals.
Just
Are we
equals?
able to just get rid of this square root? Or do
Of
we
course.
have to write out the full
No.
thing and then?
Get rid of it because they intend you to. That's why I gave you that. It's nice, right? This would be one that would be a no calculator one because it's very doable.
Katie, what'd you get?
5.
I don't know why you think I got these things done.
5.
5.
I don't know.
I did it. I got 10.5 pi.
Oh, pi. I got 5 pi.
So do we have to, we don't have to put like a plus C or anything?
Oh,
It's a definite integral.
Integral.
How do you find the area of?
No, half. That's square.
Okay. So again, this is rotated around the x-axis, right? Rotated around the x-axis, it makes a cylinder. What is the radius?
Square root of x minus 2.
Square root of x minus 2, which is f. So formula for a cylinder is pi radius x minus 2 squared times the height. Pi radius squared height. Now this is why I made you do it by hand because this is easy. What happens here? They cancel. Where we're going from where to where? 2 to 7. Okay, 2 to 7. Because it starts at 2. Whoops. Integral 2 to 7 of x minus 2 dx. So fundamental theorem. If we're not using our calculator, we do the fundamental theorem. So you have to do the integral. What is the integral of this?
1/2 x squared minus 2x.
Okay, we got to plug in a 7 and plug in a 2. So 7 squared is 49. So this is 49 over 2 minus 14. And then I got to subtract 2. 2 squared is 4. So that's 2. Minus 2 times 2 is also 4. Okay, so this half of 49 is 24.5. Minus 14, that is, 10.5. And then this would be plus 2, right? Because minus negative 2, plus 2. So this is 12.5 pi.
When we're writing it out, I asked this, but I don't know. Do we have to write the square root and then do the 2 first and
Nope.
then get rid of it? Or
Nope.
can we just get rid of it right away?
You could go right to this.
This is how easy everything is meant to
Oh, man. It's not like you're-
Yeah.
Yeah, sure.
2.5.
This one I got for.
Yep. Okay. Questions on this?
I'm just gonna plug in my calculator.
You got,
I got 10.5.
you did, that means you did the 7, you didn't do the 2.
Oh, it's 72.
Yeah, not 7 to 0. Okay.
Maybe I should. I told Big Steve my idea about.
Because that's where it's, that's, if you were to have, that's why I gave you this graph. Oh, that's the problem. Is it starts at 2. Okay, that's why.
What if they didn't give us a graph? It would have to give us a graph there, right?
If it wasn't some, or else it has to be something that you know what it looks like.
Yeah, I just assumed it was 0. Yeah,
I
I give us a graph there because we should know that.
That you
it
don't
shifted
like
right
challenges.
to
You should.
0.
Correct.
I told him I would make more money.
So that might not give us a graph.
You
Correct.
can challenge yourself. He was like challenging yourself sometimes with more money.
Okay. So,
I think it's stupid. Nah, I think it's stupid. The stuff that kids tell me about what he does in class, he should get fired for it.
Who?
The other day, I had a kid come up to me and go, "Your dad was chanting STD in class." Who just starts doing it? So I went home and consulted Dad, and he sure admitted to it. What?
Did he stop?
STD, what do you mean? For what? In history class, and he gave me the context of hillbillies, but I don't
he's
get it.
probably making an analogy. Like
Yeah,
if
about
you,
hillbillies.
about hillbillies and how people felt about hillbillies and so they were saying the things.
People remember that.
It would just make people remember that and then they'll be like, oh, I get how those people would have done it.
Yeah, then he also told me that he told his class that he'd rather talk to dog crap than talk to his class.
There are
You
days,
say you should get fired for that? I think that makes him a legend.
I think it does make them a legend. I would like to say those things to my algebra class. Okay.
Why don't you? You're clearly not gonna get fired.
I mean, you're being recorded, sharing your feelings right now.
That's why I didn't say all of the things. Okay, so we're going to take this area right here that's in the first quadrant, and we're rotating it around the y-axis.
So it's gotta be in terms of one.
In my class, he
Does that make it a
This, the R just stands for rotated, right?
R is just, like the AP test will be like, here's region R. What's the solid when R is, what's the volume when R is rotated around the y-axis or whatever? Okay, so now when we rotate around the y-axis, Caleb, please stop talking. When we rotate around the y-axis, here's something that's important for you to know, I guess, in general. Your slice that you make should be perpendicular to whatever axis you're rotating around.
I like it.
Okay, that's always true. If you look back at our other ones, our slices that we made were perpendicular to the x-axis. So it has to be perpendicular to y.
So does this have to be a time of what?
Do we have to,
Look at the clock, it goes slower, don't look at the clock.
I was on the clock for a bet and I won.
wait, how do we make this in terms of y if it's
Okay.
x squared?
Well,
Don't we just, do we make a y squared?
no,
Y
Hey.
squared dy?
no. So first of all, let's talk about the height of this cylinder.
DY.
It's dy. Okay, what's this radius?
X.
No. Its radius is just x, right? Remember, if this is the point x comma y, which it is, any generic point is x comma y, his radius is x. Now, radius is always your distance to the thing you're rotating around. That's important, distance to what you're rotating around, so there you go. So your radius is x. So what's the volume of this? Like, what's the volume of this one cylinder?
X dy.
X what?
It's squared.
X squared dy pi x squared dy. Now, this has to be in terms of y because this is a dy. Okay, it has to be in terms of y, which means I cannot plug x in, or I can plug x in, but I have to have, this is actually a really easy problem. Didn't intend it to be that easy. So if I know that y is equal to x squared, you can square root, which you don't really have to do.
Y just equals X squared.
Yes, it does, Caleb. Okay, do you see that y equals x squared?
Yeah.
If you didn't have that relationship, you would have to solve for x so that you can plug it in. Okay, y is equal to x squared, so direct substitute. Now, what are my bounds of integration? 0 to 4. Why is it 4? Because it's a y value. So, I want you to do this one without your calculator also, because it's easy. What?
How's the radius JP just x instead of x squared?
Okay, so I want you to think about this. Okay, let's say
Oh, because x squared is.
I drew this cylinder, and okay, and he's in the coordinate plane here.
X squared, which would, yeah.
Okay, what's his radius? What's this coordinate point? Any coordinate point in the coordinate plane is x. Why? So his radius is the distance from his center to the edge. So it's the same thing, center to edge.
So like the other ones, you put like an equation for y.
Well, look, what's the radius is y. Well, actually, yeah, I got you. So the radius is y because this coordinate point is x comma y.
We just know what y equals.
We just know what y equals because y equals the equation. Does that make sense? Okay.
So then it becomes
How?
y.
That is so fricked up. How are you gonna walk? That's just wrong.
Okay. What's the answer to this?
16/3,
No.
No, I got 8.
8 pi. Okay, don't forget your pi, but that's correct. So what's the antiderivative of that? Caleb, turn around, please. You guys, I need you to not worry about this right now. You have an AP test before you have graduation. So zip it. Thank you. I know that. Don't interrupt for other people.
I said it's on me, I'm taking it.
Oh, I thought you said not me. Like you're talking about the AP test. Okay, so this is half of 4 squared, which is 16 minus half of 0, which is 8. So 8, slap the pi back on the front. Okay, you guys try this one without me talking at you. Let's go. Y equals e to the x. And the line... Nope, can't do that. Okay, I'm gonna go the line y equals 7. It's gonna be big. Oh, maybe not. We're gonna take this area, we're gonna rotate it around the y-axis again. This is y equals e to the x.
Do we only care about like the first quadrant? Or?
First quadrant only. First quadrant only. Sorry, didn't say that out loud.
Like some kind of negative area, or just don't worry about it, works yourself out.
Are you talking about like if I did this?
No, negative,
No,
yeah,
we
like
don't
stuff
have
on
to
the
score
other
it
side.
in the fourth quadrant.
Well, I can't really do stuff on the other side if I'm rotating around the y-axis. Right?
So
Because,
are we bound by the y-axis?
yes, that's why that's, yes. First quadrant. First quadrant. R is in the first quadrant only.
Can you have a negative value instead of the
Nope.
We have to do this by
No.
hand.
Nope. You may use your calculator on this one.
You don't have
You don't have to. I'm pretty sure we did.
Mason.
I don't. No one calls me in any other class. I'll spam this again, bro.
Unbelievable.
No, don't you sound that's.
Do we? Because you have to set them equal to each other.
No.
Then you're telling x's don't probably add up because it's not x.
I don't know if it's just me, but I got pretty big
Do
numbers.
we square it after we find the y equals like
Yeah.
You're rotating it around the y-axis.
Y equals e to the x, so e to the x was our thing, so I just literally took it and flipped it and then squared one.
You can't just flip it. You can't say
Change
x
them
equals,
in and out.
no.
No wonder why I'm wrong. But e to the x equals y, and that's what we have.
No, but what your radius is x, right? Your radius is x. So you,
That's why I messed up.
yeah, you got to solve for the x.
I took my calculator for that minute. Just thinking. And we're looking for the intersection of the y's or the
Natural log of e is
Can you, like for our integral?
they can't.
Gotta have y's, y values, because it's dy.
Wait, are we assuming that it goes from 7 to 0?
You
Because
can't assume that.
how do we find that out?
Look at the graph.
I'm looking at the graph, it doesn't tell you anything.
Use your brain.
Yeah, which means it would just.
I think it's 1. How do you find
Use your brain.
You're supposed to just guess that it's 1?
No, you don't guess that it's
Oh,
1.
you
This
plug
is
in
0.
zero.
You plug in 0 for x. It tells you what the y is. E to the 0 is 1.
Oh.
Or you look at a graph on your calculator and find it. But e to the 0 is 1. Okay.
You plug in 0 for x.
Yeah, because that's going to tell you what this is, right? Yeah.
1.
Dang, so I need to redo that real quick.
Lily, what's your question?
Can you show us how to do this?
Of course.
Okay, what'd you get?
Did you get this?
11, no.
I got it now, yeah.
Okay.
I mean, I can do that, but I don't understand why.
Because the radius is x.
Two animal numbers.
Okay, the radius is x because this is a coordinate point xy, right? And so that's a sideways cylinder. That's this much of the graph. Its x is its radius. Well, you don't have anything that's x equals. So in our other one, like you told Garrett, we knew what y equals. So we could just write what the equation was, right? I don't know what x equals. I got to get x equals. Just to solve for x here. Anytime we're doing stuff in terms of y's, whether it's cross-sectional area or volume like this, you're going to have to solve for x.
Why have the radius being squared in the one?
I'm not done. Okay. So the radius is natural log of y. Oh, in the other one?
Yeah.
Look, if we solve for x, we get square root of y. So x is the square root of y. And the formula is pi times the radius squared. That's where it went. Okay. So then this is going to be pi, radius is natural log of y squared. There's one of them, dy, from our y values. And again, this discussion, like, what is that? It's 1 because, you guys, an exponential graph crosses the x-axis at 1. Okay, so 1 to what? 7. And you know what? I can't ask you to do this by yourself because you don't know the antiderivative of natural log, let alone natural log squared. This has to be a calculator one. No, that's the derivative of natural log, right? And so in my calculator, I'm going to put parentheses natural log of x squared dx. So I got 11.263 pi. Okay, let's try one more.
So if you math 9 that, it's just automatically right. And put it in.
As long as you put it in. The only thing that's tricky about this is like natural log comes up with its own set of parentheses. You got to make sure you close that one. And then you're squaring this whole thing. And there's a parentheses around that your calculator automatically puts in. So it's just a lot of parentheses, but yes. Okay, let's try this one. Let's go with, the equation x squared plus 2, first quadrant only, and then the line y equals 5 and I want that rotated around the y-axis.
You draw the graph for us.
Okay, talk to me. X squared plus 2, what does that look like?
This, the parabola scooched up.
Scooched up 2, right? So parabola scooched up 2. Okay, and the y equals 5 would be here.
For that last question.
Yep.
We were messing with decimals and we're just putting in our calculator anyway, why didn't we just put?
Yeah,
that
exactly.
anyway?
I would. Actually, I wouldn't, but it doesn't matter. So it's this rotation, this guy right here, that we're rotating around the y-axis. Okay, you guys try that one without me.
Do those notches mean that it's set too?
Say that again. I just didn't.
Do those notches on the graph mean that it's like?
Yeah, because this is a parabola, right? Shifted up 2. So yes, 2. Which that one you can assume because we know it's shifted up 2. You do not have to do this one by hand because, you could do it by hand. Actually, let's do it by hand.
Oh,
Yeah.
we have to do it by hand on the AP test?
Yep.
Is there no calculator for like a lot of it?
Yep.
Can you bring your own?
It's the no calculator period.
I download calculator software.
How,
No?
I don't know.
Okay. If you can verbalize it, just ask when you figure out what you're trying to ask. I did.
I didn't write down the formula, sometimes.
It comes out nice. You'll be fine.
Dude, Aiden, you're really well on your
I know. Totally.
I'm just getting next at it. He would have if I didn't say it was right.
Yeah. Oh, is that the answer?
I think so.
Oh, I don't know. I didn't finish it yet. Oh, that's right. That's why Ashley got.
How the heck did you get it done?
Oh, ay. Son of a gun, I'm wrong. I forget to do the integral every single time.
Pretty important part.
It is.
I can't use a calculator.
No, but probably close. We did not do a.
We did 7 and 2, not 5 and 2.
Yep.
Yeah, 16.5.
We did 7 and 1.
How did I get 0.55?
Did you do the antiderivative
Yeah.
of what?
Minus 2.
Okay, what's the antiderivative?
1/2 y squared minus 2y.
Yeah, you're right.
I have an integral from 5 to 2.
Yep. Plug in the 5, plug in the 2. So plug in the 5, that's 25 over 2 minus 10. Minus 2 squared divided by 2 is 2 minus 4. So it's 12.5 minus 10 is 2.5. Oh, Garrett, that's what I got. So this would be minus, nope.
No, minus and negative.
It's minus a negative. So it's plus 2. Sorry, here you go.
Starting with, do you have any more calculators?
In the, like if you sit and it's the skinny drawer that's up under the top. Nope, in my desk. Nope, up and where your right hand is.
So it's 12.
There's a drawer there.
4.5. Oh,
Yes.
Yep.
Yeah, 12.5.
12.5 minus 10.
Minus 10, so
2.5. And then this is negative 2. Minus negative 2. Because it's 2. This is 2 squared is 4. Half of that, that's 2. Minus 4. That's negative 2. 2 minus 4.
Oh, and you have to minus it.
And minus those.
My mom did that.
Okay, so minus negative 2. Okay, so 4.5 pi. Do you have any questions? Okay, I'm going to give you your homework then.
I like
Mason,
that.
I'm
I like
relocked.
that
I'm really open at Forest Reading tomorrow, so we're gonna take the AT highway. Because I already just got past that after come back.
I don't know, I don't like to stress my ability.
Except for rains. They'll cancel it and they'll give us the event still. So I'm hoping for rain. So then I can stay home.
Not sure I can.
Oh, no, sorry, we're not done.
Oh.
Oh, stop it. Okay, so,
We missed something that's gonna blow my mind, and I'm not gonna do it.
no, so to the point where we won't have homework.
What?
It was that big.
We just not have homework. The homework will be tomorrow.
Oh, can I have
Yep.
Oh,
Yep.
on the half day?
I'm like, hey, I'm gonna be absent.
Yeah, we have a whole week.
half day for prom weekend? Oh, come on, Miss Ellis, really?
And I'm a 10.
Just started with that.
Just for that comment, Barrett, man, you should give homework every single day.
This
What?
Can I be responsible and snack one now because I have AL tech, so I will help.
Because I missed
But-
the first one. I feel like you
You guys missed last half day.
Well, then, well, you passed the test.
I'm pretty sure it's from my AL.
Oh,
I don't think so.
That's what I've been
That's
told.
what they
That's
said.
what it
That's
says.
stupid.
They
Yeah,
switched it
go
to
ahead.
permanent AM.
That's dumb. Go ahead.
Instead of swapping every time.
Make sure, let me make sure it's the right one. Let me make sure. No, that's the wrong one.
We'll see.
They already did the whole thing.
Yeah. Okay, so you can't see my. Okay.
Another homework.
So we are now talking about this region. We're going to rotate him around the x-axis. Okay, so now what's the difference between this one and the other ones?
There's a gap.
There's a gap, right? So it's not touching the thing that it's rotating around. So how many of you have taken woodshop class? Anybody? So what I want you to imagine is like you are gonna have the whole if I was thinking I would have brought donuts because that would have been better. It's the entire
Oh, you can't even
it's
see
the
your
entire
problem.
thing.
It made it worse.
it's the entire thing, but it's like drilling out the center. Okay, so you're gonna do the volume of the whole thing and drill out the center, or the entire donut minus the donut hole. Okay, so observe.
Wait, which axis are we working
We're rotating around this.
The
So
drill
we find the
press.
area, but isn't there technically not a hole because if you rotate it all around, it just gets really thin. Where's the gap at?
It's right in here,
It's gonna rotate around.
Yeah.
right?
No, but there's.
Okay.
there's a hole.
Garrett, look, there's not space here, right?
Yeah.
I'm imagining a funnel.
That's what I'm saying, like,
Isn't
we
the
have to
whole
find an area of the-
Okay, anyway, please be quiet and listen to me. The entire outside, which is the linear one, minus the inside. So this has to be done. Like, I would like you to, for the first couple, set it up as 2. So let me show you the picture. I'm going to call this guy Y1 and this guy Y2 because I did not name them F or G, which was unfortunate of me. Okay, so what we got is the outside, which is the donut. Your book is boring and calls this the washer method. So if that helps you and you know about hardware, like it's a washer. Like it's got a ring on the outside and it's got something on the inside. And it's a hole. You're more food motivated?
close to the plate?
Well, you better not have a hole in
Right? No.
Well, you should do it next week.
Okay, so let's talk about the donut itself. What's the radius of the donut? Y1. It's the outside. So donut is the outside, right? This is the big one. The whole thing. So radius is Y1. What's its height? Dx. And then what's the radius of the donut hole? No. Look at right here. What's the radius? Here's the donut hole. Just Y2. Now, what people want to do. No, I don't want to say that yet, but I will tell you what people want to do, which is the trap I don't want you to fall into. So what's the volume of this cylinder in terms of, anybody find the intersection point? I got you, just a second. 0.5x plus 2. Okay. It's not going to be nice. 1.686. Okay, so this,
Should be +2, right?
How did you know to put in that? Is that the anti?
Should be 2 plus 0.5x, so it should be -2.
I said plus 2.
Oh,
Or I typed plus 2. Okay, so this is 1 point. Let's talk about what's the volume of this cylinder. Pi hanging out front.
Do you want this formula or you want this one?
We'll put it in. X squared, right? Pi radius squared dx. From 0, because that's first quadrant, was what we shaded there, to 1.686. Okay, that will give me the whole donut, jelly filled, complete donut, no holes, right? Complete donut, no holes. We have to remove the donut hole. Sorry for those of you that like the jelly filled. What is the formula for this one?
Pi on the outside.
Pi on the outside. What's,
0.
yep, 1.686. What's the radius?
That's gonna be x squared.
Yeah. X squared. So radius is x squared. Squared again because pi radius squared. Now, this gets to be a lot. It gets to be a lot when you're doing it in your calculator, and it gets to be a lot when you have to do it by hand on the AP test, which you would not with these decimals. Do not panic. So let me show you that you are allowed to condense this a little bit. I would not be ridiculous with it, but look, these are all the same. The pi's and the integrals and the dx's are the same. So you're going to do like a little magic distributive property kind of business and say, well, 686. This is 2 plus 1/2 x squared dx minus, I'm going to even be so bold as to say x to the 4th, because that reduces how many things, no dx's, sorry, dx out here. There you go. Like I just took out the front and the dx and then I put the middle stuff together. This makes it easier to put into your calculator when you're doing it in your calculator. When it's one that you have to do by hand, it makes it easier to do the integral because you're only doing that one integral. Yes, Mason?
sorry, go ahead.
So I know we did the 2 parts at first, so we can see where they each came from.
Correct.
When we actually do this, we need to show that first 2 parts that, or can we just go right to the?
You may go right to this, but you need to be careful, okay? Because this is what I was going to say. So this is what I don't want you to do. So please don't put this in your notes. I'm going to write it down so you can see it. Don't put this in your notes. This is what people do. They go just like this. They go, ooh, here's our graph. And they're like, oh, let me make my slice. And they make their slice just like this. Okay, actually, let me make it up here. You can see it better. Okay. And then they're like, hey, the radius is y1 minus y2. Okay. What's the problem with that?
That's wrong.
Thanks. Okay. The problem is that that's not the radius. The definition of a radius is from the center to the outside. This is not center to outside. It's only like the inside of some, like I can't even, like if you had a washer, like if it was a donut, I would go donut. It's only this much, and that's not a radius, right? So you have to go all the way down to both of them to get full radii because it has to touch what it's rotating around.
But it's still the right answer.
This would not, because that would be this. Okay, that 2 does not distribute in there, right? So listen, let's go to something that we've talked about before. This is equal to x plus 2 times x plus 2. It is not equal to x squared plus 4, right? This does not distribute. Okay, so you cannot put this in your calculator. It's not the same as that. Okay, don't do it. It has to be 2 separate radii squared, subtracted from each other. These are not squared, subtracted from each other. Okay, should be really careful with that. Then you subtract them. Yep, so donut minus donut hole every time. Okay, so otherwise that's the only other addition. I just would rather not give you homework right now. Let me have you try this one. We'll do 2 examples of this, not today, but 2 examples total. So let's say let's go back to our friend e to the x. And let's do y equals 4. And I would like you to rotate this first quadrant area around the x-axis. Whoop, sorry, there you go.
It's not even,
What, Caleb?
I just don't know how you can rotate around something without touching it. Like the other one that.
Yeah, I know what you're saying. So it's just that your axis is here and you're taking something that doesn't touch and you're going around.
It's just like the moon.
It's like the moon.
That's what I'm saying, this one, doesn't this one, like, so this one has a hole.
It has a hole.
When is it like rotating? I'm trying to like imagine it.
Yep.
But, I can't really do it.
No.
Like, this could be like, right here, be touching it.
If it's
around.
touching it.
But
So-
this one would have a hole.
Yes.
That's what I was
This
thinking about the last
kind
one,
of
it
like
doesn't have a hole.
But they're only touching it one place, right?
Like at 0.
Like fractionally touching it 0.
Yeah, so it's
like-
like, it's just really, really thin, but
It's-
there's not actually a hole.
correct.
It's just really,
It's
really thin.
really, really.
Well, that's what I was trying to say last time,
Yeah.
because I feel like,
That makes sense what you're saying.
yeah, but this makes sense, because if you just go around the x-axis, then
Yeah.
there's
So this is like,
this spot right here, and this.
exactly.
But like when we were doing this thing,
Which still, this does count as a whole though because of the rest of it, right? Because you still have to drill out the rest.
How do you know
of
which
it.
one's Y1 and which one's Y2?
but isn't there kind of like when you do like these other graphs? I mean, this is around the y-axis, but wouldn't this be considered a hole though, even though it's rotated around the y-axis because it's not?
But it's
not like a
touching, it's all
square.
touching the y-axis though. Every part of it is touching the y-axis. So,
right here, so
yes.
this part, since
Like if I did this one around y, I'd be fine,
yeah,
right? But I'm going around the x. So because it's not touching the axis, it's rotating. If any part of it is not touching, right? Because you got to drill out the space that's in there.
we can find this, so we can just graph it, find it, right?
The intersection, yeah, I don't know what it is. Something terrible.
It is still the interval from 0 to 4, right?
It's not 0, is it?
It's not 4. Because listen, we're going here, right?
Yeah, x equals 4, whatever x is.
Right. This is a dx, so this needs to be an x value at x equals 4.
Yeah, I lost me in my.
X equals, x, 1 point.
Yep.
And then we need to also find, so we can just plug in 0 for x, so y is that, that's how y get. We don't even know that.
Correct, because it's an x value going left to right.
Wait, it's an x value, it's not a y value, so it's 0.
So it's 0. Right, because we're going right up to the x-axis or y-axis up to that Nancy decimal. Okay, we will stop there. We will finish this up. We'll probably do one rotated around the y-axis tomorrow, and then I'll give you homework.